Hello, we are Group 1 in MEC 2502. Currently, there's a problem in Canada where $75 billion in counterfeit currency is in circulation, as the RCMP has reported. And the idea behind our project is to detect counterfeit currency and sort it based off of its value. The reason for doing so is to remove the human error when detecting counterfeit currency and to speed up the transactions in everyday life.
In order to achieve the goal of our system, we're using two basic sensors, the first of which is a camera. When the program is ready, the specimen will be loaded onto the collection tray. The camera will then take a picture of the specimen and upload it to LabVIEW's Vision Development Module. Here, LabVIEW will perform two different types of comparisons. The first is a geometric matching. In the geometric matching, LabVIEW will determine the differences between the relative edges and shapes between the specimen and the template which we provide. Then it will go through a golden template comparison. The golden template comparison will find the difference between the sample and the template on a point-by-point basis. The second sensor that we're using is a photodiode. A laser will shine a light through the transparent zone of the bill, and the light intensity will then be measured with the photodiode on the opposite side. We'll be able to adjust the range of acceptable values within LabVIEW. When the light is shone across the photodiode, it will generate a current. This output will be recorded by the potential difference across the resistor. First, however, the output must be amplified using a non-inverting operational amplifier so it can be detected by LabVIEW.
We use a single LabVIEW program to control all components of our system. Our program starts with loading the templates for the types of bills we accept. Image of the specimen is taken using the Vision Acquisition Express VI. The acquired image is first passed through three geometric matching operations, where it is compared to $5, $10, and $20 templates to identify its type. After the specimen has been recognized as either a $5, $10, or $20 bill, color of each point is compared to the color of the same area in the golden template. This comparison identifies areas with different colors and marks the defects. We accept bills with less than 3 large defects as visually authentic. This concludes the visual comparison. At the same time, the existence of transparent zone on the bill is checked. Output voltage from the photodiode circuit is read, and its difference to a reference value measured with an authentic bill is found. If the voltage difference is within the allowed range, the existence of transparent zone is confirmed. True or false results from the visual and transparency checks are passed through an AND gate. Bills with transparent zones and correct appearances are accepted as authentic. Based on the authenticity check and the value of bill identified with geometric matching, the appropriate storage unit is positioned below the chute and the trapdoor is opened. Positioning the default storage unit back below the chute and closing the trapdoor concludes one iteration of the program. We believe our system will be useful in any place that cash transactions take place, but most importantly in banks, cashiers, and currency exchange offices. We also think it will be useful as an integrated component in ATMs.